Number 11, 6 marks here, circles. You're given the equations of two circles, one in the nice form, one in the expanded form, and you have to calculate the distance between the centres of C1 and C2. I'm just going to use C1 and C2 for the actual coordinates of the centres here though. And then secondly, hence show that the two circles intersect at two distinct points, meaning that they overlap. Because that'll have to do with how far apart they are, the distance between the centres, and how far they can reach, what their radii are. Well, if I'm calling that circle 1, I'm just going to call the centre 1, because you can read it straight off. That's going to be 4, would make that a 0, and that would be -2. And the second one, it's been multiplied out. So they've just been doubled, in other words, because when you square a bracket, you just double it. So that means this time that will be a -1 and a 3, because it'll be half of those numbers with the same process. So the distance between the centres, I'll just put it this way down, will be the difference in the x-coordinates squared, the difference in the y-coordinates squared. So just do the x's first. I'll just do that one. It doesn't matter which way around you do it, you're squaring it anyway. And then, which one did I do first? This one. 3. 3 take away the -2. So that gives me a -5 squared, which is 25. And that also gives me, a 5 squared, which is 25. Which means that the distance between the centres is going to be, well, you can see that, I'll put it down anyway. It's going to be the square root of 50, but that'll be 5√2. You'd have to make it 5√2 because that's a final answer, of course. Part B, show that the circles intersect at 2 points. We'll need the radii. Let's get them again. So R1, get it straight from here, √37. R2 is more of a calculation. You could use your G's and F's, but essentially they're just going to be the same numbers as its centre. So when you square them, it'll make no difference. So that'll just be a 1 plus a 9 when you square them and add them. But take away that number at the end, so that'll be a +7. So that's √17. So that means the sum of the two radii, R1 plus R2, is this awkward number. √37 plus √17. And that's what you're going to compare. What is the situation here? Are the circles far enough apart? Is the distance between the centres more than the radius of one and the radius of the other? Are they just touching? Is the distance between the centre the sum of the radii? Or are they overlapping so the distance between the centres is less? So this number here, is √50 the same as, more than, or less than that? Well, you're probably just going to take it to decimals here. But you can actually compare them by squaring them, since it's positive distances. Comparing the numbers is the same as comparing the squares. I don't know how they would accept this, but anyway, squaring that's a 50. Squaring that would be, square the first, square the last, would be a 37 and a 17, which is already over 50, and you've still to add on twice the product, 2 times that, times that. So that's more than that. In other words, the distance between the centres is less, so you know they overlap. But rather than going through all that bit of algebra, maybe I'll just change them to decimals to demonstrate that. So this comes to 10.2, I'll just round it off, 10.2. And √50 is 7.07. I'll put 10.21. So now we can say this. D, the distance between the centres is less than R1 plus R2, as 7.07 is less than 10.21, which means the circles intersect at 2 points. That's 2 distinct points rather than 2 coincident points like the tangent circles. So number 12 from paper 2 of the 2023 Higher 4-mark question for reconstructing the original equation from its derivative. And of course you'll need some extra information. because when you undo a derivative, you introduce a constant. So this is going to be, y is going to be reconstituted. So let's rehydrate this shriveled equation. And that'll pop back up to 4 divided by 4, so that's a 2. And that'll just be 3x and then plus c. That's the bit you'll need this for, because you don't know exactly where this graph was. Well, I'll just do this at the side. Using that information says that when y is 3, x is negative 1. So from that you can find c, because that's just a 2 and that's a minus 3. So taking that across would be 6 taken by 2 is 4. So there you go. Y equals 2x to the 4 plus 3x plus 4.